Cool. Okay, as always, I am recording this, but I need you guys to look at again, follow along in your manuals as much as possible, ask questions. Nick, you may have to refresh that module, okay? If you're using the app or if you're using a browser, you may have to refresh to get to that, to get the updated module. I just updated it this morning.
Yeah, I just refreshed and it wasn't there, and now it is.
Okay, just wanted to make sure you have it. So again, I'm just going to say this once again. On the module for 519, there's an updated PowerPoint. I'll put the updated PDF out there later today. That is the current PowerPoint with a few corrections that they made. I got it this morning. Okay, nothing major, but again, it more matches your manual and page numbers. Okay. Any questions about anything we went over yesterday before I start on today's material? Okay, so today I want to talk about type 1. Okay, everything we've talked about in the core, just to make it clear, can appear on the type 1 25 questions. Okay, just because it's in core does not mean that it might not appear in the type 1 questions. So type 1 certification, what we're talking about, they're going to talk more about recovery equipment. We're going to talk about recovery requirements and recovery techniques as well as safety. Okay? Now, type 1, remember, is small appliances. So type 1 certification is required by persons handling refrigerant during the maintenance, service, or repair of small appliances, with the exception of motor vehicle air conditioning. Okay, again, motor vehicle air conditioning is a completely different side of the industry, and they have their own certification, okay? We are talking about everything with the exception of motor vehicle air conditioning. Okay, so we're talking everything with the exception. Now, the EPA definition of small appliances includes products that are manufactured, fully charged, and sealed in a factory containing less than 5 pounds of refrigerant, 5 pounds or less. Split systems, which is our residential air conditioning systems, where you have indoor unit and outdoor unit, may not be serviced by type 1 technicians. Again, the key is hermetically sealed in a factory containing 5 pounds or less of refrigerant. Split systems cannot be serviced by type 1 technicians. So think about it. If whoever installed the piece of equipment had to braze lines together, had to charge the unit in the field after installation, it is no longer a type 1 appliance. Is there any questions on this? And again, think about what's in red here. Okay, they're making a point, and these guys are the guys who wrote the PowerPoints or the guys who wrote the test. So anything in red is something we have to worry about. The sale of HFC, HCFC, HFCs, and HFO refrigerants to service or install air conditioning equipment is restricted to technicians who are EPA certified in refrigerant recovery. Now again, that doesn't mean I can't buy the 1 pound cylinders for motor vehicle air conditioning in Walmart. Okay, but that means that I can't walk into a supply house and purchase refrigerant that's being used in air conditioning and refrigeration equipment. Okay, and again, motor vehicles is a little bit different certifications. Motor vehicle-like systems do not meet the criteria for type 1 appliance certification, no matter what type and quantity of refrigerant. HCFCs and HFCs such as 404A cannot be used for new type 1 appliances. Okay, they have a restriction on these refrigerants. HCFCs, HFCs, such as 404A, cannot be used for new type 1 appliances. Does anybody know what the primary type of refrigerant we use for type 1 appliances are these days? 134A is our primary type. Doesn't have a temperature glide. Works pretty well across all ranges of temperatures. And it's also used in motor vehicles, but again, we're not worried about motor vehicles on this. When retrofitting or converting a system to use a different refrigerant, only EPA-approved substitutes can be used. Remember, as I said yesterday, there's no such thing as a drop-in substitute. EPA does not approve any substitute refrigerant as a direct drop-in to service an R22 or other type system. R22 is an HCFC. It's going away. There's no direct drop-ins. There are some refrigerants that's close. Okay, there's a thing called 422, and there's a couple others that are close, but there's no direct drop-in. And that is an EPA question that shows up quite often on the exams. Is there a direct drop-in for R22? No, there isn't. There's some refrigerants that are close that I can use, but they're not advised. Recovery equipment that's used during maintenance, service, or repair of small appliances that use CFCs and HCFCs and HFCs must be certified by an EPA-approved laboratory. Guys, you can't just buy a product from overseas in a third world country or even a developed nation and use it legally for EPA testing or EPA recovery. Okay, we absolutely have to have these things approved. They're approved through, most of them right now are approved through Underwriter's Laboratory. Okay, that's our basic approval laboratory. Okay,
hey,
has to be approved. Yeah.
Have you ever used one of the refrigerant recovery bags?
No, the interesting thing about those bags, and I think that's what we're looking at right in front of us on the screen right here, is I actually went to a parts house a couple years ago a number of years ago, when I first started teaching the EPA and tried to get one. They looked at me like I was insane.
Why is that?
I've never used one.
Wow.
Have you seen one used someplace?
No, I was just wondering because I was reading it through the manual, and that's the first time I've seen that anywhere.
And I've talked to a couple friends of mine who worked for Sears Home Central. They do a lot of small appliance repair and stuff like that. And I figured if anybody had used the bags, it would have been those guys. They've never seen them. So I don't even know if they still exist anymore. I can't find them anyplace. And it just seems like a dangerous idea to me anyway, so.
No, I would agree. One little nick, and there goes all the refrigerant.
Well, the whole idea, supposedly, is that there's charcoal in the bag, and it's supposed to be neutralizing things. I don't buy it, so I wouldn't use it. But again, they're out there someplace. Okay, persons who open or perform maintenance, service, and repair of Type 1 appliances can either use a self-contained or a passive recovery. Now, this is exactly what we were just talking about. The top one there is the recovery machine from Apion, okay? Most of our shops use the Apion recovery machines, or at least have 2 or 3, because quite frankly, they gave all the schools a couple machines per campus, okay? And I carry one around too. This is the same machine I use when I do stuff in the field. Okay, the bottom one here, the bottom picture on this slide is what's a recovery bag. Okay, it doesn't have any compressor to it. It doesn't have any moving parts. It is a bag of charcoal, okay, activated carbon charcoal, that supposedly when the system pushes the refrigerant into these bags, the chlorine in the refrigerants gets neutralized. Okay, again, I don't buy into this whole thing. I would never use it. It's dangerous for me. But that's considered a passive recovery device. Okay, and again, I've never found one. Okay, And if I found one, I probably wouldn't ever buy it. But that's a passive recovery device. It doesn't have a compressor inside of it. So for type 1, and this differs from different types of EPA certification, type 1 is allowed to use passive recovery equipment if the compressor in the system is working. They've got to have something to push that refrigerant out of the system. A domestic refrigerator is an example of an appliance that you can use the passive recovery devices. System-dependent or passive recovery equipment for use with an appliance is limited to a maximum charge of 15 pounds. Okay? That is going to be a test question. They're going to try to trick you in it. They're going to try to tell you that they have a type 1 appliance that has a charge of 30 pounds. Can you use passive recovery? Okay, well, there's two problems on that question. You cannot have a type 1 appliance with 30 pounds of refrigerant, and passive recovery is limited to a maximum charge of 15 pounds. They're going to try to trick you on those questions.
Now, you said you've never used one of those bags, but have you ever done like a passive recovery just into a cylinder itself?
Oh, yes. Yeah.
Okay.
You know where I do them the most often? You're going to laugh. When I'm working in the shops. When I'm working in the shops at school. And the reason is because we have a tendency a lot of times to get a lot of overcharged equipment in the shops. So I'll use the passive recovery just to recover refrigerant when people overcharge it.
Interesting.
It works well. It sure beats going and getting the recovery machines.
Yeah, definitely. Any step you can save is a good.
So, okay, so again, watch that question on that 15 pounds, okay? Maintenance practices for recovery equipment. You've got to check them for refrigerant leaks and oil level on a regular basis. Does anybody remember, do all recovery equipment have oil in it? We talked about this the other day. Does all recovery equipment have oil in it?
No, we said only the older equipment.
Yeah, only the older equipment. Most of the recovery machines are now oil-less. But you still got to check them for leaks. Make sure things are tightened down. You don't want to have leaks in your recovery equipment. That's just not a good thing. A refrigerant scale or an internal float device are acceptable methods for monitoring that the fill level in the recovery tanks does not exceed 80%. You cannot have recovery cylinders exceeding 80% of their fill capability, okay, of their volume. 80% is a magic number. Self-contained recovery devices for use with small appliances containing CFCs, HCFCs, and HFCs must be able to recover 90% of the refrigerant when the compressor is operating or achieve a 4-inch vacuum under AHRI 740. Again, this is something I need you guys to highlight if you're following along in the manual. 90% of the refrigerant when the compressor is operating or achieve a 4-inch vacuum under the conditions of AHRI 740. That's for type 1 appliances, for active recovery equipment. 90% of the refrigerant if the compressor is operating or achieve a 4-inch vacuum. When you have inoperative equipment, in other words, the system of compressor is not operational, the equipment used to recover must be able to recover 80% of the refrigerant or achieve a 4-inch vacuum. So when you're doing study on this, when you're studying this, you have two conditions. You have a compressor that's operational, and you have a compressor that is not operational. If it's not operational, you have to be able to recover 80% of the refrigerant or achieve a 4-inch vacuum. If it is operational, you have to be able to recover 90% of the refrigerant when the equipment is when the compressor is operating, or achieve a 4-inch vacuum. You have two things on this. Okay, two conditions. Be careful. Refrigerant recovery devices have to either be manually closed or automatically closed when disconnecting to prevent a loss of refrigerant from the hoses. Again, gotta use low loss fittings. An acceptable form of low loss fittings is the manual valves. Okay? Close the valve before you pull the hose off. I really like the manual valves on hoses. I use them myself. Okay? It's an acceptable form of low loss fittings. But you cannot have refrigerant just being lost out of the hoses. We have to be able to minimize our refrigerant loss. Okay? And by the way, that's a requirement of every type. In every type, got to use low loss fittings. When attaching a gauge set to check system pressures, again, hoses with manual or self-sealing valves on the end should be used to minimize the loss of refrigerant. Okay, we have to use low-loss fittings. And what they're showing in this picture is you can actually buy add-ons to your hoses to get low-loss fittings. Now, the gauges we give you with the toolkits, the gauges that are in your toolkits, those hoses, we give you two sets of low-loss. We give you two low-loss fittings with it. One as an angle and one as a straight. They have to be used on the hoses when we don't have a three-way valve. Okay, whenever you're using a Schrader core, those have to be used on the hoses. When filling or charging a cylinder, this is another thing that you're not going to see anymore, but it's still on the exams. When filling a charging cylinder with CFCs, HCFCs, or HFC refrigerant, the refrigerant that is vented off the top of the cylinder must be recovered. Now these, I have seen one of them. Let's see if I can describe this to you. It's a cylinder that looks just like the picture on the left-hand side of this slide. It is glass. In your truck or wherever your main recovery, your cylinder, wherever your main refrigerant cylinder is, you actually dump liquid refrigerant through hoses into this cylinder. As you're filling it, you obviously have refrigerant gases that is coming off the top of it because you have to fill this under a vat. Basically, when you put liquid into something, it pushes air out of it. So you have gases that are coming off the top of it. Those have to be recovered. Then you disconnect your full tank and you take this charging cylinder that has the specific amount of refrigerant you want to put into the system. You take this charging cylinder into the building or wherever the equipment is, you attach your gauge hose to the charging cylinder, and then you transfer the refrigerant out of this cylinder into the system. This was before we had really good refrigerant scales. Okay, this was before the digital scales came along. The charging cylinder had the weights all up and down the left-hand side of the cylinder here. Okay, if you look closely, you can see it has some scales here and everything else like that. Now think about how much could go wrong with handling liquid refrigerant in glass containers as you're carrying it in and out of people's houses. Okay, again, this is something you guys aren't going to see in the field, but it is on the exam because there's people that are still using them. Refrigerant that is vented off the top as it's being filled or after the fill is complete has to be recovered. Is there any questions on charging cylinders? Because this is a little bit of a weird thing. Okay. Again, you're not going to see these. Just know that refrigerant that is vented off the top must be recovered. A vacuum pump that's made for system dehydration may be used to evacuate a recovery cylinder to be used as a recovery device. However, you cannot use a vacuum pump to directly recover refrigerant. What this basically means is if I have a new recovery cylinder, okay, it should be in a vacuum before I start my recovery. I'm going to use a vacuum pump to put that cylinder into a vacuum. Okay, I don't want any air in that cylinder. I don't want any moisture in that cylinder. However, you cannot use a vacuum pump in place of a recovery machine. A vacuum pump is specifically to create a vacuum. It is not designed to pump refrigerant. Okay, cannot be used in combination with a recovery cylinder to do system recovery. Okay, hydrocarbons R600A is an approved refrigerant for new household refrigerators, freezers, and combination refrigerator freezers. Hydrocarbon refrigerants are not approved for retrofit into existing household refrigerators. Why? Does anybody know why?
It's like limited to a certain amount that you can use, and some systems might go over that.
Actually, both of those are very valid answers. Okay, you have systems that are not have more than the 18 ounces. Okay, we go over the approved levels, but also very importantly, the systems are not designed for it and they can explode. Okay, so again, 2 reasons, but you cannot use hydrocarbons. I don't care what type of hydrocarbon. They just tossed the number 600A here because it's allowed to be used in household refrigerators or freezers and combinations. You cannot retrofit hydrocarbons into existing systems. Not allowed. There's a serious safety concern. New SNAP regulations have approved R290, R450A, and R600A refrigerants for newly manufactured household refrigerants. Again, newly manufactured. Does it say you can use it in existing equipment? No, it doesn't. This is new refrigeration equipment. When servicing a small appliance found to be leaking, it is not mandatory to repair the leak, but it's recommended to do so whenever you possibly can. EPA does not require leak repair for small appliances, but leaks should be repaired whenever possible to conserve refrigerant. Make sure the valve cores are tight and the caps are on the strainer ports to prevent accidental depression and leaking from valve cores. Always put caps back on strainer cores. They leak. Okay? Always put caps back on. But again, you cannot tell a customer with a small appliance, I'm required by law to repair the leak. You're not. There's no law that says you have to repair the leak. That customer can get you out there month after month after month after month to put more refrigerant in that system. But it's going to be recommended to do so because repairing the leak is going to be a lot less expensive than all the service costs to put new refrigerant in the system. Any questions on that? Before beginning a refrigerant recovery procedure, it is always necessary to know the type of refrigerant that's in the system. You cannot mix refrigerants. Okay, I can't repeat that enough. Do not mix refrigerants. You have to know the type of refrigerant that's in the system. It's unacceptable to mix any refrigerants in an appliance or recovery cylinder. R744, which is carbon dioxide, is a very high pressure refrigerant and it generally does not need to be recovered. You can recover it so you can reuse it, but carbon dioxide, it does not have any hazardous material in that carbon dioxide. It generally does not need to be recovered. Okay? Where I would recover it is if I'm going to want to reuse it in the same system. Where I would probably recover it is if there was a compressor burnout and I have a lot of acid and oil mixed in with it and I don't want to contaminate the area that the refrigerant is in. Okay, like if I'm working in a restaurant system or something like that. Okay, so that's the type of areas that I would look at. When R410A or any other refrigerant is recovered from an appliance, it should be recovered into a recovery vessel that is clearly marked to ensure that mixing of refrigerants does not occur. We want to make very sure that we've clearly marked any recovery cylinders. Okay, clearly marking. We do it with tags, we do it with labels on the side of the cylinder, but we need to make sure we don't mix refrigerant. Now, you can do a comparison to a pressure temperature chart. Okay, is only valid to check for contaminated refrigerant if both the pressure and the temperature of the refrigerants are stable and known. And I had you do this on one of the worksheets. Okay, if we know what our temperature is and we know what our pressure is, we can compare it to a temperature pressure chart to see if we have a pure refrigerant. When checking for non-condensables inside a recovery cylinder containing one refrigerant, the technician must allow the temperature of the cylinder to stabilize to a room temperature before taking a pressure reading for the comparison using the pressure temperature chart. Let me explain this real quick. Non-condensable means air, nitrogen, anything that does not have a pressure temperature relationship. Okay, non-condensables. Okay, I can't condense them, so it's a gas that sits at the top of the recovery cylinder that I cannot condense. Okay, non-condensable. When I put my gauges on a cylinder with non-condensable to see what my measurement of temperature versus pressure is, my gauges are going to read one thing, my temperature is going to read another, and you're not going to have a match on the temperature pressure chart. That's what it's talking about. But it's very important that the cylinder stabilizes. In other words, it sits there for a number of hours in the same place, in the same position, so that there's no mixing going on, so that everything is at one temperature. There's not a warmer area of the cylinder, not a colder area of the cylinder. Okay? Does anybody have any questions on this slide? This is sort of important.
I'm just kind of curious how you would, if you took a pressure reading on a tank and you weren't sure what was in there, is there a way to determine whether it was non-condensables or a mix of refrigerant, or is it just anyone's guess at that point?
At that point, I'm treating it as I can't use it, and that tank is contaminated. Okay? Some people used to say, oh, well, you can just bleed the non-condensables off the top. Okay? So they'd open the top valve of the tank, the gas valve, and they'd bleed the non-condensables off until they got the vapor sort of appearance of refrigerant. That is getting more and more dangerous to do, okay, with the different refrigerants. We don't know the parts of the refrigerants. We don't know the mixes, so it's not legal to do that anymore. Okay, I treat it as contaminated at that point because you really don't know. Any other questions on this? Okay. If a technician suspects that a refrigerant in a recovery cylinder is contaminated, again, use a pressure measurement to be taken and compare it to a pressure temperature chart. If the pressure temperature relationship does not match the refrigerant, it should be turned into a reclamation facility. In other words, it has to be shipped out to be destroyed. Cannot use it. You don't want to add any more refrigerant to that cylinder. Again, you get charged by weight for destroying refrigerant. It's expensive. Okay, so again, if it's contaminated, you've got to get rid of it if it doesn't match a temperature pressure chart. It's pretty clear. Don't mix refrigerants. Some areas, some facilities may refuse to accept mixed refrigerants or charge extra for processing and destroying it. Okay? Again, it's very possible the supply house you go to with a mixed refrigerant tank may say, nope, not going to do it. We're going to charge extra for processing or destroying it. Something recently I've had a couple supply houses do is they check the refrigerant for acid. Okay, in other words, you take your tank of R22 into the supply house to turn it in. Okay, they check for acid in the refrigerant. They do a quick acid test on it. If there's acid in the refrigerant, they don't pay you for it. Okay, R22, they actually give you credit for turning in, unlike some of the other refrigerants. But if there's acid in it, they don't pay you for it, and sometimes they'll charge you extra. Okay, because it takes more to process acid in the refrigerant. Okay, all of this stuff you learn as you go on, but don't mix refrigerant.
Hey, Chris.
Yeah.
Hey, I'm sorry. My internet crashed, and I lost the last 15 minutes of this, so I guess I'm gonna have to get back and watch it after you upload it.
Okay, yeah, sorry about that. We're still on type 1. We just talked about basically the mixing of refrigerants, or better yet, not to mix refrigerants. Okay, I'll upload it right after this. The service aperture, or the process stub, typically used on small appliances, is a straight piece of tubing that is entered using a piercing access valve to add or remove refrigerant from the system. I showed this to you yesterday. The process stub, it's on the side of the compressor normally, and it's something that looks like it's pinched and welded shut. Okay, it's what's used to add or remove refrigerants from a small appliance. Okay, once you have a piercing valve on something, okay, you have an additional problem. There might be leakage. When installing any type of access fitting onto a steel system, you have to check for leaks before you proceed with recoveries. Because piercing valves tend to leak over time. They should not remain on the refrigeration system after the completion of the repair. They got to be taken off. These things leak. Okay? They should not remain on. Make sure you solder in or braze in a standard type valve. It's important. These things will leak. A passive system-dependent recovery process can capture refrigerant in a non-pressurized container. Okay, like a plastic bag. Okay, so again, in a type 1 appliance, I can capture refrigerant in a non-pressurized container. Let me toss this question out there again. I have an appliance with 20 pounds of refrigerant. Can I use passive recovery as a type 1 appliance? Anybody? I have an appliance with 20 pounds of refrigerant. Can I use it as passive recovery as a type 1 appliance?
No.
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 Why?
It's over 15.
Anything over 10 pounds?
It's over 15 pounds, but there's another problem. Type 1 appliances have a maximum of what weight of refrigerant?
5 pounds.
5 pounds.
Uh-oh.
So you have 2 reasons why you can't use passive recovery there as a small appliance. First of all, cannot use passive recovery over 15 pounds. Cannot count it as a small appliance over 5 pounds. 2 problems with that question. Okay. System-dependent or passive recovery devices on small appliances with non-operating compressors. You have to take measures to help release the trapped refrigerant from the compressor oil during refrigerant recovery. Okay, in other words, you have a passive equipment, small appliance. You have a non-operating compressor. You have to make sure the refrigerant comes out of the compressor oil during the recovery process. You can do things like heat the compressor with a heat gun. because refrigerant doesn't like staying in warm places. So you can use a heat gun and heat the compressor. You can strike the compressor with a rubber mailer to shake that oil and mix up the refrigerant in there. Okay, all of these things can be done when you're recovering refrigerant with an inoperative compressor. The easiest way is not to use passive recovery equipment, but occasionally you might be without a recovery machine or something like that. Doing this will help free the refrigerant that might be trapped under the oil in the compressor crankcase. Again, not a good idea to hit a compressor with a hammer when a customer's standing there. When using system-dependent or passive recovery process and the compressor does not run, you have to access both the high and the low side of the system for refrigerant recovery. You can't just access the low side, you can't just access the high side. You have to use two access fittings, one on the low and one on the high. Both low and high side access valves should be installed when recovering refrigerant from a household refrigerator or any other appliance, and this is designed to improve the speed of recovery. Okay, using high and low side access valves with passive equipment improves the speed of recovery. To ensure that all refrigerant has been removed from a frost-free refrigerator, you can actually turn on the defrost heater, and that will increase the liquid refrigerant's temperature and vaporize any liquid. So you can bypass the controls and you can energize the defrost heater, and that will increase the refrigerant's temperature and force it out of the system and into the cooler bag. Okay, that's one way to deal with it. Now, the appliance with an operating compressor and a completely restricted capillary tube or metering device requires only one access valve on the high side of the system. In other words, if I can't push it to the evaporator and I have an operating compressor, I can use that compressor to push the refrigerant into the non-pressurized container that's connected to the high side of the system. Think about it. A compressor pumps the refrigerant if the capillary tube or metering device is restricted. In other words, no refrigerant can flow back to the evaporator. I can push all the refrigerant into a recovery cylinder or bag. So again, operating compressor for passive equipment. You only have to have one access valve on the high side of the system. Most of you, when you're in the field, will never use passive recovery. If the pressure in an appliance is 0 psi after installing and opening a piercing valve, the recovery procedure cannot begin. Think about this. If the pressure is already 0 psi, is there anything to recover?
No.
No.
No, it's empty. It's empty. It's all leaked out. Okay, nothing to recover. When using an active recovery device, if there's a large volume of non-condensable gas in the refrigerant that's being recovered, you can have excessive pressure on the high side of the recovery machine and in the recovery cylinder. This is just a safety warning. If you have a lot of non-condensable gas in the refrigerant being recovered, you can get some really high pressures on the high side of the recovery machine. Okay, be careful. Again, active recovery. Okay, non-condensable gas in the refrigerant can be checked for by using the temperature pressure chart. Again, you take your gauges, you compare the high and low sides of the gauges along with temperature to a temperature pressure chart. You should have a match. Okay, so if we're having 80 degree, okay, if we have 80 degrees in this example, R134A, I have 80 degree on the tank, and I have 87 psi on my gauge. Okay, I'm fine. Okay, and you take the temperature in the vapor section. Okay, if I have a mix of refrigerant, I'm going to take it on the liquid side. Okay, the pressure and temperature should match what is shown on the PT chart. You guys are going to do this eventually in the shop. But again, my temperature pressure should match what is on the chart.
I'm just curious on the slide before that, if you had to recover from a system that you suspected had a lot of non-condensables, how would you proceed if it could be dangerous with the high pressures?
This is one of these judgment calls, how much non-condensables is in the system, what caused it. But for a small appliance, I would just accept the risk and use my recovery machine as normal, but I'd use a tank that has nothing else in it. I'd start with an empty tank.
Right, so a little safety measure could be to switch over tanks if you think you're getting close to pushing that.
Well, no, if I suspect I have non-condensables in a system, I'm not going to take the chance of taking a good, clean tank of recovered refrigerant and contaminating it with non-condensables. So I'm going to use an empty cylinder just on that basis alone.
Okay.
Okay. Because if I have a cylinder that's half full, let's say I have a cylinder that's half full of R22, and I have a system that I suspect may be contaminated, I'm not going to want to mix that refrigerant in. I don't know. Make sense?
Yep.
Okay. So again here, temperature pressure chart. By now we should all know how to read one. Okay. During system recovery or repair, if you have a really nasty odor, okay, I mean really nasty odor, okay, detected from the refrigerant, it normally indicates a compressor burnout. You need to watch for signs of oil contamination when recovering refrigerant on a system that experienced a compressor burnout, as the system will have to be flushed after it's repaired because there might be contaminants. Guys, more for your own information than for EPA, if you ever come across a system that you suspect had a compressor burnout, before I recover refrigerant out of it, I'm going to do a quick acid check on it. Okay, I'm going to check for acid in that oil. If I find acid in the oil, I'm going to recover this refrigerant into an empty recovery cylinder. Okay, I'm not going to mix it with my other recovery cylinders. Again, acid in a system is a problem. Okay, so I'm going to always do a test. Anytime I come across a compressor that has had an electric burnout, I'm going to check it for acid. When nitrogen is used to pressurize or blow debris out of a system, the nitrogen may be vented to the ambient air. You do not need to recover nitrogen. Okay? So if I'm using nitrogen for leak testing, if I'm using nitrogen to blow debris out of a system, the nitrogen may be vented to the air. Now, does this mean that I can put nitrogen into a full system to avoid refrigerant recovery? Can I put nitrogen into a full system to avoid recovery?
No.
No. Because it's very specifically said that in our EPA core, remember? Okay, it cannot do that. But if I use nitrogen to pressurize or blow debris out of a system, I do not have to recover nitrogen. By the way, can I just connect that tank of nitrogen itself to the system without using the gauges that are down in the bottom portion, without using the regulator?
No.
Why? There's a specific EPA rule that tells us why. Why?
Is it because that tank is under extremely high pressure?
Yeah, it's under extremely high pressure. Number one, that's one reason, but the bottom line reason is there's a pressure relief on that regulator. I have to have a pressure relief device. Okay, that's the absolute reason. okay, according to EPA. I have to have that pressure relief that's on that regulator. But the real reason, for a safety point, that tank may be under 5,000 psi of pressure. If you put 5,000 psi of air pressure into your gauge hoses are going to blow into tiny little pieces. Don't do it. Okay. Household appliances charged with HC refrigerants, which is hydrocarbons, require permanent safety markings on or near any evaporators, exposed refrigerant tubing, machine compartment, and the exterior of the refrigerator. Hydrocarbons, propane, isobutane, other stuff like that has to be marked very, very clearly that it's hydrocarbon refrigerants. This is for safety reasons. When recovering refrigerants, safe work practices include wearing safety eyewear, butyl-lined gloves when connecting and disconnecting hoses. Have to use them. When using nitrogen to service or leak test or purge refrigerant systems, the nitrogen tank must be equipped with a regulator. Okay. Because refrigerants are heavier than air and displace oxygen, a large refrigerant leak can cause suffocation. If a large leak occurs, such as from a filled cylinder in an enclosed area, and no self-contained breathing apparatuses are available, vacate and naturally ventilate the area. If you have a refrigerant leak when you're in a basement, get out of the basement. Okay, techs die over this. If you have a refrigerant leak in a basement or in an enclosed machine room, get out. Don't try to be the hero. Get out of there. Okay? Most times, refrigeration and air conditioning technicians work by themselves. You're not going to have a buddy with you who can help get you out of the space if you start to die. Okay? Most of us, when we've been dispatchers in the past or service managers, if we know we have somebody who's working in a machine room, or if we know we have someone working with refrigerants someplace out there, if we know we have someone working in a basement around a possible hazardous area, we will check in with that technician about every 20 minutes for a very good reason. Okay, it's not to be a pain in the butt to the technician, it's to make sure they're still alive. Okay, so again, if you have a refrigerant leak, okay, get out of the area. Okay, it is extremely dangerous. This is not just for EPA, this is for your own health and safety. At high temperatures, CFC and HCFC refrigerants can decompose into phosgene gas, hydrochloric and hydrofluoric acids. Who can tell me what phosgene gas is? Some of you here have had the refrigeration term already. Tell me what phosgene gas is. I'm pretty sure there was a PowerPoint in it that talked about that. Anybody?
Is it mustard gas?
Very close. It's part of it. Very close. When you are brazing line sets, okay, if you're brazing copper that's on a refrigeration system, specifically with R22, that's our biggest problem. If you're brazing a system that had R22 in it, or has R22 in it, or had R22 recovered from it, which is probably the biggest condition, and if you see a green flame, normally your torch flame is yellow and blue, but if you see a green flame, do not breathe anywhere near to that. Hold your breath, put your torch out, and walk away from it. Okay? The green flame is a sign of phosgene gas. Now, phosgene gas, you will not feel the effects immediately. Okay, if you breathe in phosgene gas, you're going to go about the rest of your job there, probably for an hour or so, and you're going to feel fine. Phosgene gas will hit you about an hour and a half to 2 hours after you complete the job you're on. Okay? 9 out of 10 times, that's while you're driving. Okay? Guys, I emphasize this not just for the EPA. I don't want to see anybody in here ever get hurt because of this situation. Phosgene gas, green flame while you are brazing. Stop, walk away from it, ventilate the area. Don't inhale. It's a good way to die after you're leaving the job site. Any questions on that? This is sort of important. Okay. Any questions on type 1? Because that's basically type 1. Little short, isn't it? Think they can come up with 25 questions out of that?
Yeah.
Okay, yeah, they're going to come up with 25 questions out of this, but some of those questions are going to be from core as well. Be very aware that just because it's type 1 does not mean that they will not pull questions from core. Okay? Now, type 1, again, is small appliances. How many people in this group want to just be regulated to fixing window air conditioners and refrigerators for the rest of your career? Okay? Don't do it. You want to pass type 1 because you want to be able to get universal. You want to pass core because you have to. Okay? But primarily, most of us are talking about type 2. Okay? Guys, could someone tell me, I just want to verify something on the notes of this slide. Is your type 2 starting someplace right around page 19 of your manual?
Yeah.
Okay. Type 2.
I have 22.
What was that?
Oh, wait, no, I have page 19, sorry.
Okay, thank you. I just want to make sure these notes are right because I'm going to scream at them if they're not. Okay.
Hey, Chris.
Yeah.
Where do we find the Type 2 PowerPoint at?
I haven't split it up yet, but it's down. The older version is down in the prior version is down in the Type 2 module. I think it is labeled. Hang on. It's labeled actually with today's date on it. Today's the 21st, right? Oh, hang on. Let me solve that issue.
And the full manual?
The full one, the full manual is in the core section, okay?
Oh, thank you very much.
The full manual is in the core, and the full new version of the PowerPoint is in the core. Okay? The Type 2 is in today's module, EPA Type 2. Ignore the quiz. I'm not giving you, ignore the quiz. There is none. Ignore that lab. Don't worry about that. Okay?
Hey, Chris, this is Eric. I finished last term. Would I be able to get some access to some of this information?
Yeah, Eric, do me a favor. Send me an actual email message and just tell me you need access to the course. I'm not going to put you in there as a student. I'll find some other way to give you access that you don't end up in my grade book by accident.
All right, sounds good. Thank you.
Okay. Any other questions? Because I am going to move on to Type 2 right now. Okay. Type 2 certification, what they're going to test you on is system classifications, determining proper charging, leak repair requirements, leak repair timeframes, Section 608, leak repair regulations, record keeping, how to find leaks, recovery techniques, okay, refrigeration system liquid line accessories, suction line and compressor accessories, and system evacuation. Okay, so again, a lot of this is still left over from core, but they're going to review it again in Type 2. Type 2 is very important, okay, because Type 2 is the majority of our systems. Okay, so again, technicians maintaining, servicing, or repairing or disposing of medium, high, or very high pressure appliances, except small appliance and motor vehicle air technicians, must be certified as Type 2 or a universal technician. I've said it before, everybody in here gets universal. There's no reason why you can't. Okay, so motor vehicle. We don't deal with motor vehicle. It's a separate certification. Small appliances. Why can't a Type 2 technician work on small appliances? What's the reason? You're certified as... What was that?
The pressure's higher.
No.
The system for a higher pressure?
No, you're digging into it too much. How about because you're not certified as a Type 1 technician?
That's fair.
Okay? Bottom line is the EPA says that in order to service small appliances, you have to be a Type 1 or a universal technician. If you just have a Type 2, you can't touch small appliances. So that ice machine in that restaurant kitchen your boss wants you to service, oops, can't do that. Can't do it. Okay, so again, you want to get universal so you can do everything. Air conditioning appliances, okay, in order used to supply cooling, in order to control heat or humidity in occupied facility, is determined by the EPA as comfort cooling for the leak repair category. Again, if I'm using air conditioning to supply cooling in order to control heat and or humidity, it is considered comfort cooling. Residential, office, and commercial buildings are included in this category. Okay, now, appliances to preserve products, okay, such as our freezer cases, cold storage warehouses, are classified by the EPA as commercial refrigeration. Okay, big difference between the two for leak repair requirements. Comfort cooling, making people comfortable, controlling humidity. Commercial refrigeration, storage, food, commercial refrigeration. If a system has a dual use, okay, the maximum leak rate is determined by the highest percentage of use. For example, if a company uses 55% of the system's cooling capacity in one of its manufacturing lines of refrigeration and 45% of its cooling capacity to air condition the office spaces, it's considered industrial process refrigeration. So again, maximum percentage of use. And in terms of leak repair requires, this is a big difference. Okay, this is actually pretty important. The last time I saw an EPA exam, there were 3 questions in the Type 2 certification that came back to this. Okay? Because again, we're basically telling a customer, your leak rate threshold has been exceeded. We can no longer just add refrigerant. Okay? McDonald's, Burger King, and a lot of the other fast food restaurants now have dual-use systems. They might have one large unit on their roof with a manifold situation that some of it's used for hot water, some of it's used to cool the ice machines, some of it's used to cool the walk-in, and then a very small percentage of it is actually used to cool the building. Okay, so again, dual use. To determine the system charge, look at the equipment nameplate. Okay? When you need to find out what the system charge is, especially for leak rate calculations, you have to look at the nameplate. Okay, especially if the system is a packaged system charged at the factory. The charge in field pipe split systems can be calculated using the factory charge plus the charge added for piping and accessories. On every nameplate, you're going to see, even on a split system, you're going to see a section of the nameplate that says factory charge. Okay, if it's a split system, in other words, condensers outside, air handlers inside, you're going to know, if you look at the manual, if you look up the manual online, you're going to find out how long of a line set that factory charge is for, and then you'll have an adjustment number for every extra so many feet of line set. We've added a number of pounds of refrigerant or ounces of refrigerant. So you take that factory charge and you add in the line set differences. A leak rate of an appliance can be calculated when topping off or recharging a system due to a lack of charge. Okay, it's in percentages. How much of the system, how much of the refrigerant have I had to replace? The unit nameplate is the easiest way to check the type of refrigerant used in a packaged rooftop system. Okay, in addition, the nameplate will indicate the system's total charge. The best method to charge a system that has both an air-cooled condenser and an evaporator with a nameplate charge of 80 pounds is a liquid charge by weight through the liquid line service valve. Again, best way to charge a system is to charge it by weight through the liquid line service valve. The EPA leak repair requirements apply to all appliances using a regulated refrigerant. Once the threshold leak rate has been exceeded on any system using an ozone-depleting refrigerant with a size of 50 pounds or greater, the owner must repair the appliance enough to bring the leak rate below the threshold, or they have to retrofit or retire the appliance. 50 pounds or greater, once the leak rate has been established or exceeded, it has to be repaired, retrofitted, or retired. Does the average residential system ever have 50 pounds of refrigerant in it?
No.
No.
Nope. Okay, so this 9 out of 10 times will not apply to residential. As of January 1st, 2019, the maximum leak rates are 10% of the charge per year when used for comfort cooling, 20% of the charge per year when used for commercial refrigeration, 30% of the charge per year when used for industrial process refrigeration. Folks, this slide, know these numbers. Seriously, know these numbers. 10% of the charge. So, if I have a rooftop air conditioning unit that has 50 pounds of refrigerant, okay, and if I go out there and in my first visit of the year, let's say it's in April, I put in 3 pounds of refrigerant. My second visit of the year in June, I put in another 3 pounds of refrigerant. At that point, I can no longer charge that system. That system has to be repaired because 10% of 50 is 5. Once I exceed the 5 pounds, I can't do anything with that system anymore. Questions? Okay, and this is where that dual-use system comes into effect. The reason that's so important, and the reason you have to know that, is if you have a dual-use system that's used for comfort cooling or commercial refrigeration, The customer's always going to try to convince you that the majority of the use is commercial refrigeration so that they don't have to repair the system. Okay? Again, if it's commercial refrigeration versus industrial, the factory manager is always going to convince you that it's used for industrial process because they can get away with more leakage. So there's some clear guidelines on that. Okay? These three numbers are extremely important. Know them. This is a flashcard moment for those of you using flashcards. If an appliance with 50 or more pounds of a regulated refrigerant has exceeded the threshold leak rate, the equipment owner has 30 days to repair the appliance so that it leaks below the threshold limit. And they have to conduct an initial verification test unless the EPA grants additional time. Okay? Now the EPA has yet to grant additional time to anybody. Fix the thing. Okay, but the law is, if it has 50 or more pounds of a regulated refrigerant and exceeds the threshold leak rate, the equipment owner or operator has 30 days to repair the appliance so that it leaks below the threshold limit and conduct that initial verification test. Okay, we talked about the initial verification test during our core. Okay, unless the EPA grants additional time. Okay. If an appliance with a charge of 200 pounds or more of a regulated refrigerant passes the initial verification leak, a follow-up verification test must be conducted within 10 days. So again, we have a different number here. Last slide, 50 or more. We have an initial verification test. Now we expand on it. If that appliance has over 200 pounds of regulated refrigerant and has passed the initial verification test, a follow-up test must be done within 10 days. Not having a certified technician available for service cannot be used as a reason to extend the appliance leak repair deadline. That is an EPA question that I've seen on the exams. They're going to ask you, what happens if a technician is not available to go do a follow-up leak test? Nope, not an excuse. Call another company. Okay? Not having a service technician available for service cannot be used as a reason to extend the appliance leak repair deadline. If after repairing a leak in an HCFC rack refrigeration system used in a supermarket, the system fails the initial leak verification, the technician has a 30-day window to make additional repairs or develop a retrofit plan. Again, if we have a system that fails the initial leak verification, the technician has a 30-day window to make additional repairs or develop a retrofit plan. A rack refrigeration system is just a type of a system, okay? But again, 30-day window to make additional repairs or develop a retrofit plan. Assuming no extensions apply, a cold storage warehouse operating an appliance charged with an R22 or any other regulated substance leaking above the threshold rate can continue to operate the appliance without repair for 12 months before it must be retrofitted or repaired. So they basically made an exception for cold storage warehouses with R22 and any other regulated substance. They basically said, cold storage warehouse, you can continue to operate the appliance without repair for 12 months. Okay? If the leak system rate exceeds 125% of its charge in a full calendar year, a report has to be submitted to the EPA describing the efforts to identify and repair the system leak. Further action must be taken by repairing, retiring, mothballing, or retrofitting the appliance. Okay, again, if you're up at 125% of its full charge in a calendar year, a report has to be submitted. An appliance using an ozone-depleting refrigerant does not need to be removed or mothballed by storing in a warehouse at the facility to extend the leak repair deadline. Okay, the repair deadline can be extended by temporarily shutting down the appliance, recovering the refrigerant from an isolated section or the entire system to at least atmospheric pressures. In other words, I don't have to remove it to mothball it. Okay? I can just recover the system, okay, and I can get it down to atmospheric pressure. In other words, there's no more refrigerant that's going to leak out of it, and that's enough to satisfy the EPA that I've basically done something with the system. I've taken it out of use. That extends the leak repair deadline. It's called mothballing or temporarily shutting it down. Don't have to cut it out. Don't have to move it. Don't have to do anything else to it. Just have to pull the refrigerant out of the system. Once the owner or operator has 18 months to retrofit or retire a leaking appliance if a replacement appliance will use a refrigerant exempt from the venting prohibition. In other words, if the owner of the equipment says, I'm going to go to another piece of equipment that uses another refrigerant, for example, like carbon dioxide, okay? The owner of the system has 18 months to make that change. And again, we're talking some pretty large appliances here, so we give them, the EPA is giving them time to get the money together and get the funding together, get proposals in to replace the appliance. That doesn't mean they have 18 months to make the repair if they're just going to want to make a repair. Okay, that falls under the prior categories. There's a chart in your book. I think this is on page 20 of your manual. And if someone could let me know that that's where it is. I think
that's correct.
Okay. This chart applies to both Type 2 and Type 3 appliances. Guys, I hate saying memorize a chart, but memorize a chart. Okay, you will not have access to this chart when you're taking your exam. Puts everything in one place that we just talked about. Okay. So, and again, the leak repair requirements are the same for Type 2 and Type 3 appliances. We haven't talked about Type 3 yet. Okay, same thing. Commercial refrigeration appliances and industrial process refrigeration with a full charge of 500 or more pounds of an ozone-depleting refrigerant or substitute refrigerant will require a leak inspection to be conducted every 3 months unless refrigerant leak monitoring system is installed. Again, I'm tossing another number at you. 500 or more pounds of refrigerant. You have to conduct a leak repair every 3 months. Okay? When they talk about substitute refrigerant, are HFOs included in this number? HFOs. Or HC refrigerants. Substitute refrigerants. Anyone want to take a guess here? The wrong answers are fine.
No, it's only for refrigerants that include chlorine.
Well, no is the correct answer. The reason is a little bit different. Can I use 500 pounds of the HFO or HC in a system right now?
No, you can't.
Okay, so no is the correct answer, but the reason is because I cannot use 500 pounds of HFOs or HCs in a system right now. 18 ounces is my max. Okay. Now, what about carbon dioxide? How does carbon dioxide apply here? Is it an ozone-depleting substance? Anybody?
No.
No. So, do I have to do leak repairs if I have 600 pounds of carbon dioxide in the system? Yeah, I do, because it's a substitute refrigerant. In other words, if I have over 600 pounds of refrigerant in the system, I have to do leak inspections. Okay. Industrial process refrigeration. This is large commercial stuff. I think I showed when I was doing refrigeration last term with a group of people. I showed some pictures of some ice machines that I took. Large commercial process refrigeration. In other words, you're making a product. An industrial refrigeration system containing 1,000 pounds or more of R22 that has exceeded the leak rate threshold must be inspected for leaks every 3 months until a verification that the leak rate has not been exceeded for 1 year after the repair. In other words, once I exceed the leak rate, I have to make the repairs, but then I have to check it every 3 months until it has held steady for 1 year. Again, another number, that's 1,000 pounds or more of R22. Guys, a 1,000-pound system is a very large system. Okay, they probably have people that are dedicated to keeping that system under repair. But again, once a large system like that leaks, we have to start doing every 3 months verification for at least 1 year until we can prove it hasn't leaked for 1 year. The record of leak inspections, initial leak verification, and follow-up verification tests must be kept on file for 3 years. The owner and/or operator of the equipment is responsible for keeping the records. In other words, when you hand over the customer's copy of the service ticket, they're responsible for keeping these records. You, as the contractor or technician, are not. It's the owner and/or operator of the equipment that have to keep the records you give them. Okay? And they're going to ask you about something on this. After assembly and installation of a split system, the unit should first be pressurized with an inert gas, such as nitrogen. Sometimes nitrogen is also referred to as dry nitrogen, and leak tested. Okay? What is an inert gas? Can anybody tell me what an inert gas is? Okay, an inert gas is a gas that does not have a temperature-pressure relationship. In other words, once I put it in the system and pressurize it, let's say I pressurize the nitrogen charge to 200 pounds, no matter what the temperature does, it's still going to be 200 pounds of nitrogen. That's why we like using it in car tires and stuff like that. But the bottom line is, if I put 200 pounds of nitrogen into a system, I could come back the next day, 2 weeks later, or 3 weeks later, and it doesn't matter what the temperature is, the nitrogen pressure should still be the same. If it isn't, there's a leak. Okay, that picture on the left-hand side is showing you a refrigeration line with a brazed joint and soap bubbles. I still like soap bubbles. It's my best way of checking a system. When absolutely necessary, dry nitrogen with a trace amount of the system's designed refrigerant can be used for leak detection. For example, if an R407C system needs to be leak checked, you can mix a little bit of R407C in with the nitrogen. And the reason we do this is so our electronic leak detectors work properly. But electronic leak detectors will only take you to the area of the leak. It will not take you specifically to the leak. Use soap bubbles. Visual leak inspections. That is my primary way to inspect for leaks when I go look at a system. Okay, when you first inspect a system, look for oil. If there's oil someplace where there shouldn't be oil, for example on condenser fins, that's where the leak is. Okay, because oil goes around and round with the refrigeration system at all times. Look for oil. Oil traces on rotating shaft seals of a belt-driven compressor is an indication of a leak, especially if the compressor has not been used for several months. Okay? Look for oil. But remember, when we first started this yesterday, I pointed out shaft seals. Shaft seals as a primary point to look for leaks. To pinpoint refrigerant leaks, testing with soap bubbles is the best. Okay? Guys, you don't have to buy specialized soap bubbles. Dawn dishwashing detergent works wonderfully mixed with water. I've been known to use window cleaner from my truck if I have a gallon of window cleaner in my truck. Okay, the windshield washer fluid works great. Anything that has soap in it that bubbles works really great. Okay, yellow leak detector that you see over on the left-hand side there specifically for refrigeration. Do not use gas pipe leak detector. It's too thick. You won't find the leaks. Use something that's a lightweight bubble. Don't use a syrupy stuff like you see in the gas leak detectors. Okay, excessive superheat is on a cab tube system is an indication of a leak. Remember, superheat tells me how full the evaporator is. Excessive superheat in a cab tube system is an indication of a leak. Evaporator doesn't have enough refrigerant in it. It went someplace. Okay? And that is where we are going to stop today. Okay, so tomorrow we'll continue with the Type 2 and I'll start talking about Type 3. That is where we're going to stop today. Any questions?
Have a good day.
Okay, Eric, if you are still on the line, Eric from the night class in York, if you